Electrical resistance tells us how hard it is for charges to flow through a component. When a current flows through a wire or a component, electrons collide with the atoms in the material. These collisions take away energy from the electrons and slow them down. That's what causes electrical resistance. Let's take a look. The symbol for resistance is capital R, and thank goodness for that after all these Q's and I's. The unit for resistance is the ohm, and that's named after George Ohm, the German physicist. We give the unit the symbol, the Greek letter omega, and that kind of ruins it, doesn't it? Ohm also gave us Ohm's law, which describes the relationship between current, voltage, and resistance. In equation form, it looks like this. V equals I times R. That's where V is the potential difference or voltage, I is the current, and R is the resistance. In words, Ohm's law says that the current through a component is proportional to the potential difference across it, assuming that the temperature remains constant. And that's kind of important. A resistor is a component that we put into a circuit to help us regulate the current. We often use them to protect other components from high currents so they don't go pop. Here's an example of a resistor problem. A resistor has a potential difference across it of 6 volts. The current flowing through it is 2 amps. What's its resistance? Well, R is V over I. We can find that from the triangle. Here's the triangle, or just by using your maths to rearrange the equation. The voltage is 6 volts, the current is 2 amps, 6 over 2 gives us 3 ohms. Don't forget your units. Let's look at another example. A lamp has a resistance of 10 ohms and a potential difference across it of 5 volts. What's the current flowing through it? Well, I is V over R. The voltage is 5 volts, the resistance is 10 ohms, 5 over 10 gives us 0.5 amps. If you combine resistors in series, then to get the total resistance of all the resistors, you just add them up. Here's an example. In this circuit, we have a 6-volt battery supplying 3 resistors. We want to work out the current. To work out the current, we need to add together all the resistors to get the total resistance in the circuit. 60 add 40 add 20 gives us 120 ohms. The current is now the voltage divided by the resistance. I equals V over R, which is 6 over 120, which gives us 0.05 amps. Before I give you one last useful tip about resistance, can I just ask you to like and subscribe? It just helps me grow my channel. I've also got lots of free resources on my website, and I'll leave links to all that in the description below. There's questions and answers to go with this and all my other videos. I offer one-to-one lessons as well with myself and revision courses, so I'll leave links to those in the description. So then, if a wire has a resistance, what happens to that resistance when we double the length of the wire? Well, we make it twice as hard for the charges to get through, so the resistance doubles. That means the resistance of a wire is proportional to the length of the wire. If we make the wire thicker, it's actually easier for the charges to get through. That means the thicker the wire, the lower the resistance. Thanks for watching. Now watch this.